Alright, I'm Gavin. So this is the lab 4 with op amps. So here we have the inverting op amp. So we don't have the leads going in since they're connected to this one. But what this does is we have these two resistors, and you take one input goes into the negative terminal of the op amp, and then based on the ratio of these resistances, it amplifies that as well as inverts it to your output, since this is negative feedback from the output into the one of the inputs of the op amp. So then your output is some multiple, as you see here, as well as negative. So this yellow is our input and the blue was our output, which is inverted and multiplied. So then we have this, which is a voltage follower, and this doesn't have any resistors on it, so all it's doing is taking in the input on one of the inputs, and since the output is connected back to the other input, the output tries to match that other input, and so the output is exactly what your input is. So then you get following like this. These divisions are different, but these are the same voltages, and they're in phase together with the square wave. And then here we have the differential op amp, and so what this does is it takes the difference between the two inputs and then multiplies it by a constant gain that is based on the ratio of this resistor to this resistor, which is the same as the ratio of this to this. And this can be used because this allows the op amp, which is normally a differential amplifier, to be used within its linear range, since we're greatly decreasing the difference between the two. And so then for the inverting, we also see here that right here they have an amplification, and so we see a gain across the different, this is a network sweep, so we see a gain. And then for and then for this one, we also, in order to find the slew rate, we don't have a screenshot of this, but we took a cursor and measured the Y distance here, and then the X distance where we see this little curve because it's just getting up to that voltage there. So that X distance, and that's essentially like a slope, which is our slew rate. And then for this one, the differential amplifier, we have, as you can see here, it takes the difference, which is the blue, and amplifies it. And so, as you see here, the ratio of these resistors, it was 120 kiloohms to 12 kiloohms. And so the peak-to-peak of the input, which is the difference between the two inputs, is 1. And then the peak-to-peak output is 10 because it's multiplying that by 10, which is the common mode gain that we have for this circuit. And yeah.